As another tangible model of what's going on here, let's take our foam chunk, trace its projection into the XY plane, the rectangle, the delta X by delta Y projection. And let's put a domino across the top. Now you remember this familiar foam chunk. We have a kind of a downward slope as we go in this direction, kind of an upward slope as we go in this direction, so that the domino doesn't lie at just one angle with respect to the XY plane. It lies at an angle that has a component in the X direction and a component in the Y direction. We can see that this pen has a component that goes this way, the direction of this pen has a component this way, has a component this way, as well as its component upward. The normal vector then, that is the vector normal to whatever surface lies above this region down here, could be written as n, let's get a better pen here, as n equals negative fxi minus fyj plus k. So that n makes an angle which we'll call gamma with the vertical direction such that cosine of gamma equals n dot k divided by magnitude of n, magnitude of k being 1, so that the cosine of gamma just equals n dot k divided by magnitude of n. K being, of course, the vector in the vertical direction, and the reason the vertical direction is important is the vertical direction is perpendicular to our area increment down here. Now let me point out that if this domino and this domino are oriented at angle gamma, so that let's put this domino along this direction and this domino along this direction. Okay, so if this angle here is gamma, then the full length of this domino up here is going to correspond only to this portion of the domino we have down here. So let me mark that off and let's just say okay. Now I've got this region here which is going to be my region of the XY plane, and I've got this region up here which is the region corresponding to part of my surface. The area of this region is much less than the total area of this region. The ratio of the surface area to the area in the XY plane is what? Well, the ratio of this to this is the hypotenuse of a triangle divided by the side adjacent to the angle gamma. That's the secant of gamma. which is just the reciprocal of the cosine of gamma. The cosine would be the adjacent side divided by the hypotenuse. So that's the reciprocal of the cosine of gamma. The cosine of gamma is just this simple vector calculation, so that if we know the normal vector, we can easily calculate the cosine of gamma without ever having to calculate gamma itself. And that's just going to be the magnitude of whatever normal vector we happen to be using divided by the dot product of that normal vector with the k vector. Now you might object to the fact that these two dominoes, and let's see if I can find the right two dominoes, these two dominoes were in a plane that could be interpreted such that this normal vector, if this is down in the plane, this normal vector has zero component in the y direction, and in general our vectors, our normal vectors to planes, do have components in the y direction. So is there something unique about the way I oriented these dominoes, or does this generalize? I claim that it's obvious that it generalizes. If I take my normal vector here in this configuration, my normal vector having components in the k and the I directions only, and just rotate the system, now my normal vector has components in all three directions. The ratio of the area on this surface to the area that we get if we project it down onto the lower surface is still equal to the ratio of the n vector to its projection in the k direction. So the n vector still makes the same angle with the z direction, with the k direction, as it did before I rotated it. Okay, the k direction being here. And now we are not confined just to a model where the n vector is in the xz plane, essentially. Now there are other things you might object to here, so we're going to do a little more general proof, but there's a plausibility argument for the fact that the ratio of surface area up here to surface area down here to the projected surface area in the plane is done by this simple calculation.